You wake up this morning and decide to make coffee instead of tea. You feel like it was your choice, your decision, your free will exercising its power over the universe. But what if I told you that this decision was already written in the stars billions of years ago? What if every neuron firing in your brain, every synaptic connection sparking to life, was just following the cold, mechanical laws of physics like dominoes falling in an elaborate cosmic chain reaction that began at the moment of the Big Bang? Picture this. You're sitting in your kitchen right now, and you believe you're choosing to continue reading these words. Your brain feels like it's weighing options, making decisions, steering the ship of your consciousness through the stormy seas of daily life. You feel the weight of responsibility, the satisfaction of choice, the very essence of what makes you human. But according to the fundamental laws that govern our universe, that feeling is nothing more than an elaborate illusion, a beautiful lie your brain tells itself while reality unfolds according to equations written in the fabric of space-time itself. The atoms in your brain are dancing to music they have no choice but to hear, following rhythms established when the first subatomic particles began their eternal waltz through the cosmos. Every decision you think you're making was predetermined by the precise position and velocity of every particle in the universe at any given moment. The coffee or tea choice wasn't yours to make. It was physics making it through you, using your neurons as its computational machinery to execute a program that was compiled 8 billion years ago. This isn't philosophy or speculation. This is what the hardest of hard sciences tells us about the nature of reality. And once you truly understand what physics has revealed about causation, determinism, and the mechanical nature of everything, including your thoughts, you'll never look at yourself the same way again. The implications are staggering, terrifying, and absolutely revolutionary. We're about to embark on a journey that will challenge every assumption you have about choice, responsibility, consciousness, and what it means to be human in a universe governed by immutable physical laws. Do you really believe you have free will? Before you answer that question, consider this. Every thought you've ever had, every decision you've ever made, every moment of creativity or inspiration might be nothing more than inevitable chemical reactions unfolding in your brain according to the same laws that govern falling rocks and orbiting planets. The very fact that you feel like you're in control might be the cruelest joke that physics has played on consciousness. We've been taught to think of ourselves as the authors of our own stories, the captains of our mental ships, the final arbiters of our choices. But what if we're actually just extremely sophisticated biological machines, executing programs written by the laws of thermodynamics and quantum mechanics? What if the sensation of choosing is just your brain's way of creating a narrative after the fact, a story it tells to make sense of processes that are actually running on autopilot? Think about the last important decision you made. Maybe it was choosing your career, picking your partner, or deciding where to live. You probably spent weeks or months weighing options, making lists of pros and cons, feeling the weight of responsibility as you contemplated different paths. But what if that entire deliberation process was just your consciousness watching a movie that had already been filmed? What if the decision was actually made by unconscious neural processes milliseconds before you became aware of it, with your conscious mind simply taking credit for something that had already happened? This isn't just academic speculation anymore. Neuroscience has been accumulating evidence for decades that our sense of agency, our feeling of being in charge, might be a fundamental misunderstanding of how our brains actually work. The question isn't whether this evidence exists. It's whether we're brave enough to confront what it means for our entire conception of human nature, moral responsibility, and the meaning of existence itself. Let me take you back to 1814, when a brilliant French mathematician named Pierre-Simon Laplace had an idea that would haunt philosophy and physics for the next 2 centuries. Laplace lived in an age when Newton's clockwork universe seemed to explain everything, when the movements of planets could be predicted with stunning accuracy, and when mathematics appeared to be revealing the hidden order underlying all of reality. He was watching the total solar eclipse of 1806 from his observatory outside Paris, marveling at how astronomers could predict these celestial events down to the second, when a thought struck him with the force of revelation. If we could know the precise location and momentum of every single particle in the universe at one specific moment, Laplace reasoned, we could use Newton's laws to calculate the entire future and past of reality. Everything that would ever happen had already been determined by everything that came before it. He called this hypothetical superintelligence Laplace's demon, and in his 1814 work, A Philosophical Essay on Probabilities, he wrote that for such an intelligence, nothing would be uncertain, and the future, as the past, would be present to its eyes. Think about what this means. In Laplace's universe, your decision to read these words was determined by the precise arrangement of molecules in your brain, which was determined by every meal you've ever eaten, every conversation you've had, every photon of sunlight that hit your retina, all the way back through an unbroken causal chain to the initial conditions of the Big Bang. The butterfly effect isn't just poetry, it's physics. The position of every hydrogen atom in the Andromeda Galaxy right now has some infinitesimal but real influence on whether you'll have eggs or cereal for breakfast tomorrow. Laplace himself seemed to understand the terrifying implications of his insight. In the same essay, he wrote about how this deterministic view would make human pretensions to free will appear to be only a chimera. But he also acknowledged that this level of calculation was beyond any real intelligence we could imagine. The equations were too complex, the variables too numerous, the computational requirements too staggering. So practical determinism remained theoretical determinism, a philosophical puzzle rather than a lived reality. Newton's laws seemed to support Laplace's vision perfectly. When you drop a ball from a tower, its trajectory is completely determined by gravity, air resistance, and initial velocity. There's no moment where the ball chooses which path to follow. It simply obeys the mathematical relationships encoded in the structure of space-time. If human brains are made of the same matter that obeys these same laws, how could our thoughts and decisions be any different? The neurons in your head are governed by electromagnetism. The synapses fire according to chemical gradients, and the entire intricate dance of consciousness unfolds according to the same principles that govern everything else in the universe. But here's where the story takes its first dramatic turn. Laplace's beautiful, terrifying vision of absolute determinism began to crack in the early 20th century, when physicists started peering deeper into the fundamental structure of reality than anyone had ever looked before. What they found wasn't the clockwork precision that Newton and Laplace had imagined, but something far stranger and more unsettling. The universe, it turned out, had dice built into its very foundations, and even God, according to Einstein's famous complaint, seemed to be playing with them. But before we explore how quantum mechanics shattered the deterministic dream, I need you to pause for a moment and really think about what we've just discussed. If everything you are is just particles following laws, what does that mean for the sensation you're having right now of thinking these thoughts? Put your thoughts in the comments below, because this is about to get much, much stranger, and I want to know where your mind is at before we dive into the quantum rabbit hole that awaits us. Enter Richard Feynman, the physicist who perhaps understood better than anyone how to think about the weird, counterintuitive world that modern physics revealed to us. In the 1940s, while working on quantum electrodynamics, Feynman developed a completely new way of visualizing and calculating quantum processes. His famous Feynman diagrams weren't just mathematical tools. They were windows into a reality so strange that it challenged every assumption about how cause and effect actually work. Feynman once said, "Nobody understands quantum mechanics," and he meant it. Even the people who could manipulate the mathematics with breathtaking precision couldn't make intuitive sense of what the equations were telling them about the nature of reality. The quantum world operates according to probabilities rather than certainties. When you measure an electron's position, you don't find it in a specific location because it was always there waiting for you. You find it somewhere within a probability cloud that describes where it might be. The very act of measurement collapses this cloud of possibilities into a single reality. But before that measurement occurs, the electron exists in what physicists call a superposition of all possible states. This isn't a limitation of our knowledge, it's a fundamental property of reality itself. Heisenberg's uncertainty principle tells us that we cannot simultaneously know both the position and momentum of a particle with perfect precision, not because our instruments are inadequate, but because the particle itself doesn't have definite values for both properties until we choose which one to measure. The universe is literally uncertain at its most basic level. But what does this quantum indeterminacy mean for the question of free will? If the universe isn't deterministic after all, if there's genuine randomness built into the fabric of reality, does that provide the gap that consciousness needs to exercise real choice? Unfortunately, the answer isn't as comforting as you might hope. Random isn't free. If your decisions are determined by quantum coin flips in your neurons rather than by classical mechanical processes, you're still not in control. You've just traded slavery to determinism for slavery to chance. A decision made by cosmic dice rolling in your synapses isn't any more yours than a decision made by classical mechanical processes following Newton's laws. Feynman understood this distinction with characteristic clarity. He recognized that quantum mechanics had introduced genuine uncertainty into physics, but he also understood that uncertainty isn't the same thing as agency. When quantum events occur in your brain, and they definitely do occur constantly, they're not expressing your will. They're expressing the fundamental probabilistic nature of reality. Your consciousness isn't controlling the quantum processes, it's emerging from them. And there's a crucial difference between those two relationships. The strange thing is that both deterministic and quantum mechanical descriptions of brain function lead to the same uncomfortable conclusion. What we experience as free will is something other than what it appears to be. Consider what happens during the simple act of making a decision. Let's say you're choosing between vanilla and chocolate ice cream. Your brain processes taste memories, nutritional information, social associations, maybe even unconscious factors like how the words sound or what each flavor reminds you of from childhood. Thousands of neural networks activate, compete, and interact in patterns so complex that even our most sophisticated brain imaging technology can only capture shadows of what's actually happening. But every single step in this process, whether it follows classical physics or quantum mechanics, operates according to the same principle. Prior states determine future states through mathematical relationships. The neurons firing right now in response to the word chocolate are responding according to how they've been shaped by every previous experience you've ever had with chocolate. The synaptic connections that strengthen or weaken during this decision-making process are following biochemical rules that were established long before you were born. Even if quantum effects introduce some randomness into the mix, that randomness isn't coming from you in any meaningful sense. It's coming from the same probabilistic processes that determine when radioactive atoms decay or how electrons behave in atomic orbitals. Your brain is certainly doing something remarkable. It's processing information, weighing options, and arriving at a conclusion that feels like a choice. But the you that feels like it's making this choice might be more like a passenger in a sophisticated vehicle, experiencing the journey, but not actually steering. The sensation of agency, the feeling that your conscious mind is driving the decision-making process, could be a story that your brain constructs after most of the real computational work has already been completed by unconscious processes that operate according to the same physical laws that govern everything else in the universe. This brings us to one of the most disturbing experiments in the history of neuroscience, conducted by Benjamin Libet in the 1980s. Libet asked volunteers to perform a simple task: flex their wrist whenever they felt like it, while monitoring both their brain activity and their conscious awareness of deciding to move. What he discovered sent shockwaves through both neuroscience and philosophy. The brain showed a pattern of activity called the readiness potential, several hundred milliseconds before people reported being aware of their intention to move. The brain was preparing for action before consciousness knew it had decided to act. Subsequent experiments have refined and extended Libet's findings, using more sophisticated brain imaging techniques to peer even deeper into the decision-making process. Modern neuroscience has revealed an even more startling picture of how decisions actually unfold in the brain. Using advanced fMRI technology, researchers have been able to predict with remarkable accuracy what choice a person will make up to 10 seconds before the person reports being consciously aware of their decision. 10 seconds is an eternity in brain time, billions of neural events occurring while consciousness remains completely unaware that a choice has already been made. These experiments typically involve simple decisions, like whether to press a button with the left hand or right hand, but they reveal something profound about the relationship between conscious experience and neural processing. The prefrontal cortex, which we associate with planning and decision-making, shows distinctive patterns of activity that correlate strongly with eventual choices long before the person experiences the moment of decision. It's as if consciousness is the last to know about decisions that have already been made by unconscious neural processes. Dr. Michael Gazzaniga, one of the pioneers in split brain research, described the conscious mind as the brain's interpreter, constantly creating narratives to explain and make sense of actions and decisions that have actually been initiated by unconscious neural systems. This interpreter isn't deliberately lying to us. It's doing exactly what evolution designed it to do, creating a coherent sense of self and agency that helps us navigate social relationships and plan for the future. But the stories it tells about being in charge might be fundamentally inaccurate descriptions of how decisions actually get made. Think about the last time you had a sudden insight or creative breakthrough. One moment you were struggling with a problem, the next moment the solution appeared in your consciousness fully formed, as if it had been delivered by some mysterious mental process you couldn't observe or control. That's exactly what was happening. Your unconscious neural networks were working on the problem continuously, exploring different combinations of concepts and associations until they arrived at a configuration that satisfied whatever criteria your brain uses to recognize good solutions. Then, this solution was presented to consciousness like a gift, complete with the satisfying feeling of having figured it out. The same thing might be happening with every decision you make, except that instead of experiencing the solution as a sudden insight, you experience it as a choice that you've deliberately made. Your consciousness receives the output of unconscious decision-making processes and constructs a narrative about having been in control of those processes, even though the actual computational work was performed by neural systems that operate entirely below the threshold of awareness. This doesn't mean consciousness is useless or epiphenomenal. Conscious awareness plays crucial roles in learning, planning, and especially in social coordination. But its role might be more like a sophisticated user interface than like an executive control system. The implications of these discoveries extend far beyond academic psychology and neuroscience. If our sense of free will is indeed an illusion, what does that mean for moral responsibility? How do we hold people accountable for crimes if their actions were determined by physical processes beyond their conscious control? Some philosophers and legal scholars have begun arguing for what they call hard incompatibilism, the view that free will is incompatible with both determinism and indeterminism, and that we need to completely restructure our approaches to ethics, law, and social organization based on this understanding. But others argue that the illusion of free will might be so fundamental to human psychology and social functioning that we should continue to act as if we have genuine agency, even while understanding that this belief might not correspond to physical reality. The neuroscientist Sam Harris has argued that understanding the illusory nature of free will can actually be liberating, reducing our tendency toward blame and punishment while increasing our capacity for compassion and rational social policy. If people's actions emerge from causes beyond their ultimate control, perhaps we should focus more on changing those causes rather than punishing the effects. Meanwhile, GPS satellites orbiting Earth have to constantly adjust for relativistic effects that would cause navigation errors if we ignored Einstein's insights about time dilation. The same physics that reveals the mechanical nature of human consciousness also enables the technologies we rely on daily. Particle accelerators use quantum mechanical principles to probe the fundamental structure of matter. Medical imaging techniques depend on our understanding of how electromagnetic fields interact with biological tissues. The computer or phone you're using to read these words operates according to quantum mechanical principles governing how electrons behave in semiconductors. Every technological achievement of the modern world depends on physical theories that describe reality as a mechanical system operating according to mathematical laws. We don't usually think about the philosophical implications of our technology. But every device around you represents a confirmation that the universe operates according to discoverable principles that don't require conscious intention or free will to function. The same mathematical relationships that engineers use to design microprocessors or spacecraft also govern the neural networks in your brain. The boundary between biological and artificial information processing might be much less clear than we typically assume, especially as we develop artificial intelligence systems that can perform increasingly sophisticated cognitive tasks without any form of consciousness or subjective experience that we can detect. This brings us to what might be the most profound question raised by the intersection of physics, neuroscience, and our understanding of human consciousness. If we don't have free will, what exactly do we have? The answer that emerges from modern science is both humbling and magnificent. We are conscious witnesses to an extraordinary cosmic process, biological systems that have evolved the remarkable capacity to observe and understand the universe from within. The fact that this understanding challenges our intuitive sense of agency doesn't diminish the wonder of existence. It transforms it into something even more extraordinary. Consider what had to happen for you to be here reading these words. Billions of years ago, simple molecules began replicating themselves in the primordial oceans of Earth. Through countless generations of variation and selection, these molecular systems became increasingly sophisticated, eventually developing the capacity for metabolism, growth, and reproduction. Some lineages evolved nervous systems that could process information about their environment. Some developed brains that could form memories, recognize patterns, and anticipate future events. Eventually, some evolved the capacity for language, abstract thinking, and the ability to contemplate their own existence. You are the current instantiation of this 4 billion-year process of increasing complexity and information processing capacity. Your brain contains roughly 86 billion neurons, each connected to thousands of others through synapses that can modify their strength based on experience. The total number of possible patterns of neural activity in your brain exceeds the number of atoms in the observable universe. This biological computer that emerges from your neural networks can contemplate mathematics, create art, experience love, and wonder about the nature of reality itself. The fact that this magnificent biological machine operates according to physical laws rather than some supernatural principle doesn't make it less remarkable. It makes it a direct manifestation of the universe's capacity to understand itself through the systems it creates. You are not separate from the cosmic process that created you. You are the cosmos becoming conscious of itself through billions of years of evolution and development. The laws of physics didn't constrain your existence, they enabled it. The deterministic or quantum mechanical processes occurring in your neurons right now aren't preventing you from having thoughts and experiences. They are precisely what makes thoughts and experiences possible. This perspective shift from seeing ourselves as separate agents acting upon the world to seeing ourselves as expressions of the world's own deepest nature can be profoundly transformative. It doesn't necessarily resolve all the practical questions about moral responsibility and social organization, but it offers a different framework for thinking about these issues. Instead of asking whether people deserve punishment for their actions, we can ask what kinds of interventions will most effectively promote well-being and reduce suffering. Instead of focusing on blame, we can focus on understanding the conditions that lead to different types of behavior and working to create environments that encourage flourishing rather than destruction. The conversation we're having right now illustrates perfectly how remarkable this process really is. Through millions of years of evolutionary development, matter organized itself into biological systems capable of processing information about their own nature. These systems developed language that allows them to share complex ideas across space and time. The thoughts forming in your consciousness as you read these words represent the universe engaged in self-discovery, using the neural networks in your brain as instruments for exploring the deepest questions about the nature of existence itself. If you're finding this perspective shift compelling, or if it's raising questions you want to explore further, hit that like button and subscribe for more content that explores the intersection of science and human experience. What we've discovered through this journey into physics, neuroscience, and consciousness is that the universe is far stranger and more beautiful than our everyday experience suggests. The sensation of being a free agent making choices is real as an experience, even if it doesn't correspond accurately to the underlying physical processes that generate our thoughts and actions. We are not the authors of our own stories in the way we typically imagine, but we are extraordinary expressions of the universe's capacity for experience, understanding, and wonder. The elimination of free will from our scientific worldview doesn't eliminate meaning, purpose, or beauty from human existence. It relocates these qualities from the realm of supernatural agency to the realm of natural emergence. Meaning isn't something we impose on a meaningless universe. It's something that emerges naturally from complex information processing systems that evolution has equipped with the capacity to value, appreciate, and understand. The love you feel for other people, the satisfaction you get from creative work, the awe you experience when contemplating the night sky. These are all real phenomena produced by real physical processes in your brain. They don't become less real when we understand their neural foundations any more than a rainbow becomes less beautiful when we understand the physics of light refraction in water droplets. Understanding the mechanics doesn't eliminate the experience, it deepens our appreciation for how extraordinary these experiences are as expressions of what's possible in a universe governed by mathematical relationships. Perhaps most importantly, recognizing the illusory nature of free will can increase rather than decrease our sense of connection with other people and with the natural world. If your actions emerge from causes beyond your ultimate control, then so do everyone else's. The person who cuts you off in traffic, the politician whose views you despise, the friend who disappoints you. They are all expressions of the same cosmic process that created you, shaped by circumstances and neural patterns that they didn't ultimately choose. This understanding can cultivate compassion without eliminating the practical need to respond appropriately to different types of behavior. We can still work to prevent harmful actions and encourage beneficial ones, but we can do so from a place of understanding rather than moral outrage. We are not separate agents struggling against each other in a hostile universe. We are temporary expressions of the universe's own evolution toward greater complexity, understanding, and perhaps even wisdom. The next time you feel the sensation of making a choice, remember that you are witnessing one of the most remarkable phenomena in the cosmos. Matter that has organized itself into patterns sophisticated enough to contemplate its own existence and imagine alternative possibilities. Whether or not you have ultimate agency over that process, you are undeniably a participant in it, and that participation is extraordinary enough to merit a lifetime of wonder, exploration, and appreciation for the magnificent accident of consciousness that allows the universe to experience itself from within.